Alrighty. So it's been a while since I've worked on this since the first video we did. Primarily, the first video we were looking at discovery, finding local Scuttlebutt peers on a local network. I've since worked quite a bit on this off stream, unfortunately. But I want to talk a little bit about where things stand today and where or what we might do today. So first thing is made a lot of progress. So one thing that I will show is that basically the whole client side protocol is now done, right? So we can start up a peer and then communicate with another server and send the client hello messages and then finish a handshake, right? So if we look in the protocol, we have basically this client hello message, this client authenticate message, and then basically finally validating the accept at the end, all done. And so we can take a look at that. So the way that I typically test this is I run the SSB server, the Node or JavaScript version from GitHub. And basically we spin this up. It's running on basically a local local item, and this is gonna connect to my patchwork instance, but that's okay. So it'll take a minute here. Let's sure. Yeah. So if I start this thing up, basically we'll see a bunch of stuff go back and forth here, or at least we should. And basically this client will spin up, send the initial hello message right from the protocol, and then it will, the server will acknowledge, and they'll kind of talk back and forth for a moment and then be done. So let's spin this up and see what we get. Looks like I haven't started up this instance in a while since I've been using Patchwork a bunch locally. So this might take a moment, but we'll see what we get here. We might have to stop it and change to another profile, but this should be fine. And actually, while this is working, one other thing I wanted to point out is that there is now actually a pretty good implementation of this in Java, of both a server and a client and a bunch of other kind of crypto-related tasks. So if I ever get stuck or anything like that, like this is usually a pretty decent reference. Oh, and you'll see it ran over here. Let's go. Yeah. Okay. So basically, you'll see here, right? These four things. So this peer spun up, it found a client, right, locally. This is my local IP. It's running on port 8008. And basically it sends a message, right? And if we look at the thread here, oops, we look at this peer discovery thread. Basically what this does is once it finds it, it then creates a client key exchange object. And then basically first it sends the hello message. If the hello message was verified, right, meaning we sent it to the server sent it back. Once that's verified, the server sends us hello. And then what we do is we send basically a client, or we do a shared secret derivation. So we get this back, we read it, we verify it, and then basically if that hello message, right, that we got from the server was verified, we then do a client auth, right, which is kind of the third step in the process. And then basically the server sends us a message back. We then have to validate that and accept that. So one thing I haven't quite done yet so far is the kind of validating the server accept, but you know, you can see here, right, this sent it back over, and so basically this is the end of the handshake from a client. So this Kotlin code, right, this handshake is now done from that perspective. And what I want to work on a little bit today is the server side of things. So if we go over here, we have a bunch of different client messages, right? So we have verify, which verifies the hello, deriving shared secrets, computing signatures in the secret box. So these are all kind of the operations, right, that the client does. And you'll see basically there's the client interface, right, is just basically sending a hello message, right? And we'll pull up the protocol, right? So we're just sending a hello message, right, which is this. We're then reading the hello message, which is like this section right here. And then we're sending a client auth, right, which is this client auth. And as I mentioned, the server sends an accept back. We're not doing anything with that yet, but I figured at this point, right, it's probably good enough to go ahead and get a server side exchange going, because then rather than continuing to run the node version, right, letting this thing index, which can take forever if you're even a sort of active member on the network. That way I can then run both the Kotlin client code that I wrote and the Kotlin server against each other, right? So, if you're going to run this in an Android app or on a desktop app or whatever in the future, right, you're going to need both. So, and I'm almost at the point now where basically the two things can actually, are starting to get to the point where they can talk to each other. So that's going to be pretty cool. So, we're actually going to use the client that I wrote because I know that it works to now kind of test or talk to the server, if you will. And we'll go ahead and try this out. So let's go ahead and look back at the protocol and see what we need to do. So like I said, we did the client work already. So for example, if we were to look at the client hello, right, what this does, it's basically doing this this crypto auth, right, is this kind of representative of this. And if we look at the hello, is that the hello message? Yeah, that's the hello message. So essentially we're sending our ephemeral key pair, the public key, and the app key, which is essentially the network identifier, right? So this is a static, this static byte array that kind of says, hey, I'm on the main Scuttlebutt network. So so that's essentially this message right here, right? And we're basically concatenating the tag, right? Which is basically this crypto auth, this NaCl auth, libsodium auth, and then the ephemeral public key as bytes, right? So that's that message right there. So we now want to do the opposite of that, which is basically the server verifying that is indeed a valid message. So let's go ahead and do that. So server key exchange, and the way that this is meant to work is each one of these like exchanges, right, it uses a new key pair. So you don't really want to like you can't reuse this, or you're not supposed to reuse this. So basically whenever you see appear, you will kind of create a new one of these so that you're not reusing key pairs, right? Because you have both kind of a long-term key pair which identifies you, and then a short-term or an ephemeral key pair, right, that you use for the handshake. So so we're gonna have a method, right, that's probably similar to what the one above is, right, or the client is. And basically we're going to read this, and we're probably going to want to return a Boolean saying that hey, this message is valid, right? The server is then going to basically, so the first thing I want to do is just make sure that the length is 64. So if it's not 64, we can just basically bail out, right? Because we know this isn't a valid message, so that's easy. And then basically we have to split the message apart, right? So remember the message that we sent was a combination of this libsodium crypto auth set of bytes, and then the key pair of the client, right? So the first thing that we're gonna do is basically split these two things. Dot slice, and so basically this is going to be 0 until 32, and then the client ephemeral public key is going to be hello dot slice 32 until 64. So those are our two things, and I'm guessing we're going to want to store this locally for this exchange. We'll get to that in a bit, but I'm pretty sure that we're going to want to store that. So now comes the fun part. So now is where we kind of call into lazy sodium or libsodium, right? Lazy sodium is the Java wrapper around this. Now we're going to call into that to make sure that this thing is validated or it's verified. Okay, so we're going to do lazy sodium. It's probably crypto auth verify. Guessing, yeah, crypto auth verify. And a lot of these methods have kind of easy helpers, right, that take in a string versus a byte array. And I initially when I was doing this, I was having a lot of trouble getting the string methods to work for whatever reason, and basically I got so frustrated with it I gave up. So I pretty much always use kind of like the lower level ones, right? Which again, this is still quite a bit higher, but at least when I'm working in bytes, I don't have to worry about any of the encodings or anything like that. So, so essentially what it's going to do is it's going to return Boolean. We're passing the tag, the message that we got, which is essentially a client key, and then the app key at the end, right? So we're going to send in the client HMAC, the client's ephemeral key, and then the network key. And so we think we passed the network key in here. Yeah, it's this way. So let's just do it the same way. So we will assume that we have, we will assume that we're going to have this app key passed into us because, again, right, we want to support maybe being on different networks. We're going to pass in this app key, and then this is also taking in an integer. That's not one. More than one of these. Oh yeah, crypto auth verify. That this is really the one that we want to call. And this is basically the length of that we send in to the actual bytes. So this is basically client ephemeral key public key dot size, right? So basically we're calling that and saying verify it, and then we can effectively just return this value. Array found list. Oh, yeah. And this isn't, we're not saying that this is efficient. We are just making this work. We'll come back to this. And And then, yeah, this is .toLong. Okay. Actually, we can let's just do this up here so that we're not doing this in line. Done. All right. So this read hello message looks good so far. Okay, so now we have to spin up this server and then send it a message from our peer that we created, right? So we are gonna need probably a new thread just for testing anyways. This is, we're gonna make all this use non-blocking IO in the future, but for now we need a new thread, which is essentially the server thread, and then we'll spin this guy up. So it's going to look very similar to the peer discovery. So I'm actually just going to copy this. Server thread for now, whatever. All right, we're gonna run this by default on a different port. So that they don't clash. The typical port that you run it on is 8008, but we'll do it on a different one. Screw this up, yeah. Factoring probably goofed that up a little bit. All right, so the idea is that we'll run these two things together. One thing that we're gonna have to do is we're gonna have to kind of like trick this guy into, because this server thread doesn't or we could make the server thread do it, but this server thread doesn't necessarily like send out a message broadcasting itself, right? So it doesn't send out that peer message. So we'll have to figure out how to fake that real quick. But let's go ahead and see how that might work. Essentially, basically going to be listening for a packet. Local server thread. And then basically we're going to do server key exchange. And this is going to be the only thing we have to pass in is the main network. And then basically once we receive the packet, we're going to read everything off of it. And see if it's okay. So if it's true, we'll verify it. If not, oops. This is basically going to be invalid. Invalid hello message. Okay. So now if we start this up, go back to the protocol for a second. When we start this up, basically the server basically has to, or in this case, right, again, it's just a peer, but it has to basically broadcast itself to the other one, to the peer, to the client in this case, and then basically that's what kind of triggers the client to call it, right? So you'll see here in the client, it basically is sitting here waiting for the first discovery message, and then it tries to parse that peer. And if it finds one, then it goes ahead and sends that over. Okay, so what we're gonna want to do is send that message first, and then wait for this guy to call us. So basically we're going to do something like socket.write, and we're going to send out a packet, val peer. We're going to call this the advertisement packet, right? And this is packet. And so this is basically going to be the byte array for now. So basically we're going to send this packet over the network. This person's going to discover it, and then basically it's going to parse it and then start the handshake. So, oops. Yeah, so basically we're going to send the advertisement packet. Does return anything? Do we need to look at anything? Yeah, it doesn't. So first we send the advertising packet. This thing will pick it up. It'll parse the peer, and then it'll basically start the handshake, right? So there is a method that basically shows what that peer is, but let's just go ahead and do this from the specification, right? So what does this have? So it has basically the IP, the port that it's running on, and then basically the long-term public key of this person. So in that case, we can steal a couple of things from the peer discovery thread, right? So as soon as this starts up, it basically does a key exchange. And first thing we do is we have to create a key pair, which is the identity. So that's this crypto sign key pair. So, and again, this is kind of just for testing, right? But we're going to have basically, this is kind of the identity of the server, and we're going to be sending the public key, right? The base64 public key right here, right? So that's kind of this string essentially. And we're going to need access to sodium, which that's because it's over here. For now, we can just throw another instance over here. It's no big deal. Okay, so our message is gonna look something like this. It's gonna look something like net : IP. It's then gonna have socket.port, that. And then basically the base 64 of the public key. So identity.public key dot as we can do it as bytes, and we're going to basically do base 64 dot get encoder dot encode, and we're going to encode the public key, right? And one thing we also, oh, and then we need the actual IP, right? So socket dot inet address. See here what 2-byte array, and then this is going to be we'll make it a byte array, bytes dot size. So let's go ahead and just run this and see what this looks like, right? So this is basically going to be peer. We'll kind of call this client thread so we don't mix them up. Server thread, client thread, client thread. And then this is really the server thread. All right, so now start and then server thread dot join as well. Okay, so if we run this, the client's going to start up, server's going to start up, and then let's just go ahead and like look at what all this stuff looks like, because I don't know if this is right. Let's go ahead and start this up. Yeah, right. Yeah. Okay, so we have to debug this. Socket. Because it's not going to have that, right? So really, going to have a port though. No, multi. Oh, this is just saying how can you right. So if it receives, so let's just do I think it's because there's nothing there because we haven't actually called receive or anything like that, but we also need to tell it the IP. So let's just hard code this for now. Make it easy on ourselves. So 11.171. Actually, was it 171 or 71? 171. Okay. So basically we're saying, hey, we're listening here on port 8009 because it's a server. And then we'll see what we get. Okay. Okay, so it's a little hard, probably a little hard to see, but basically dot encode. Oh yeah, this has got to be dot to string. Not doing what we want. That is not okay. Base64 encoder.get encoder. Actually, what is this? As plain string. Does this basic? No, that doesn't base64 encode it. Do we unencode it here? Yeah, we do need to encode it, right? Let's look back at the protocol. Base64 of the public key, and base64 encoded public key without at or ed. Yeah, okay. So base64 code to string. There we go. All right, that's probably going to look better. Yeah, that looks a little better. Okay, so you'll see, right? SHE equals blah, 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 blah. Okay, so now if we send that, oh, is this gonna? Yeah, here's the fun of socket program. I haven't done this in a while. Okay, so if we send this, is it gonna get caught somewhere else? No, it's not, because probably because the inet thing wasn't there. And I have to refresh my memory on Java UDP send packets. There's like a connect step or something like that that I'm missing. You know, like it has to bind to something before it can actually send. Echo server socket.receive datagram socket while running. No, it can receive right away. Oh yeah. Yep. That's what I forgot. That's what I was missing. I knew that there was something going on here. So that's interesting though. It's basically saying that. All right, so we can do socket.send buff length address. Okay, yep. So the new packet that we're going to send is going to go to 8008. And we can do this. And then we can start to pull this stuff out. That will give us the address. And then this is saying we can just send it. And it's probably because, yeah, no buffer, no address, right? Peer discovery, it found one. Probably because, and what does it look like? Peer. Got peer discovery message packet.length. Dun dun dun. Go to the next one. Oh, it didn't get anything. Got peer discovery message, length 128. We haven't even sent it yet. So this is gonna hold here. And then oh no, is there something else? Oh, this guy's on the network. Let's turn that guy off. Let's turn that guy off. Okay, so we're gonna hang here until we've got a peer. And this is gonna get sent out. Let's debug this a little. And we actually want to send this out. So localhost is this. Localhost address. What's that going to give? Yeah, 127.0.1.1. Okay, that's fine. This is going to be 8008. No, this is going to be 8009 because this is our socket. So basically, we're sending net. Ooh, that's not right. Yeah, that's what we want. Host address. All right, so we're about to send a packet that looks like net:127 localhost 8009, and then basically our key. We send that, it will block there. We got a peer. That's good. Post this, public key that, okay. And then basically what we're going to see is this thing will send a message, and then we should block once we've received the message, which is here, and we'll see what we get. Nope, didn't like that. Okay. Oh, that's right, because we don't have an actual socket running, a TCP socket running to accept that connection. Okay, so that's the multicast socket. Now we need an actual TCP socket up and running. On port 8009, you know, waiting for that. So, oops, equals server socket. It's going to be ports 8009. Okay, so then in here, so first we want to accepts it. Method blocks till connections made. Yep. All right, so now we're not going to do this. We're going to accept client socket. And then we're going to read client socket get input stream read. And first, for now, we're just going to read 64 bytes. This is taking in basically a buffer. Yep. So create a, oh, we already have a buffer, which is here. And then basically we're going to pass this buffer dot slice. Well, let's just pass the whole buffer. Basically, we're going to val hello. Really, the hello message is equal to the buffer dot slice 0 until the length, and this should be 64 bytes. That's a byte array. Oh yeah, 0 until length 2-byte array. So this is the real hello message, and when this happens, yep. So this will basically hang here until it gets a message. Right. Now let's do this again. All right, so this side's working pretty good, so I can wait on that. Okay, so we accepted. We are now creating a new key exchange object. The message that we got, the length was 64. And then let's verify it, and it says, hey, it's verified. So that's great. So, so again, right, what we're doing in this case, go back to protocol. So our client has sent this message, and then we just verified that that message was okay. And from that message, we actually got a lot of useful information, right? We got the ephemeral public key of that client, right? Which we'll then be able to use as part of our ability to derive keys later. So I think that's about all we're going to work on today. Just a quick little stream, but we got some more, so that's pretty cool. So